Hello everyone, myself Pranjal Sharma. Through this video lecture, I want to give some basic introduction on vectors and scalars. So, vectors and scalars are basically the physical quantities. So now, what is physical quantity? When we study physics, actually we study the laws of nature. In physics, we study systems, and in any system, it has certain properties. Those properties can be measurable, and the quantities through which we can measure those properties are known as physical quantities. Suppose if we want to measure hotness, degree of hotness or coolness of a system, then there is a simple quantity known as temperature through which we can measure its hotness or coolness. Similarly, the quantity like mass, density, charge, volume, all these things can be measurable. Now, these physical quantities are classified into, as I have already mentioned, as vectors and scalars. Now, scalars are those physical quantities which have only magnitude. They have only magnitude but no direction. No direction associated with scalars. Some examples of scalars are mass, charge, density, temperature, etc. Simple mathematical operations like addition, subtractions, that means simple algebraical mathematical operations are applicable for scalars. In case of vectors, it have both magnitude and direction. It have both magnitude and direction. Some examples of vectors are velocity, force, momentum, etc. For vectors, special kind of mathematical operations are required for addition, subtraction, and multiplication. Now, how can we represent a vector? We can represent a vector by simply using arrowhead. Any vector, suppose A, can be written as this. And there are several kinds of vectors which we need to study. Some of them are here I want to mention here. Some of them here I want to mention. Suppose we have considered a reference frame. Reference frame means a three-dimensional Cartesian coordinate system where, suppose this is a classroom where O is the origin, suppose a corner of the classroom, and this is a dust particle present on the location, suppose that is location 1, suppose P1. So we have to locate this particle by a simple vector known as position vector. Suppose this is R1 is the, here R1 is the position vector. So this vector is known as position vector. Let this particle move to a certain point P2 after some time. So the particle changes its position, that is the particle displaced from its earlier position. Now the new position vector will be R2. Since the particle moving from point 1 to point 2, that means the particle displaced, so we have express it through another vector known as displacement vector. This is known as displacement vector. Let the displacement vector be r. R be the displacement vector. Then r is equal to r2 minus r1. Beside position vectors and displacement vectors, there are some other vectors. Suppose a vector has a unit magnitude and in a specific direction. Before going to that this vector, I have to mention about the magnitude of a vector. Suppose A is a vector, then its magnitude can be written as A is equal to square root of A square. Let's a vector which has magnitude equal to 1. Suppose X is a vector which magnitude equal to 1. Then this vector is known as unit vector. And often this vector is written not like this, but this. This is known as cap, X cap. In any textbook on physics, in general, there are 3 unit vectors are most usually used. Most generally used 3 unit vectors are the unit vector along x direction, unit vector x direction. It can be represented by I cap. Similarly, unit vector along y direction represented by j cap, and unit vector along z direction represented by k cap. All these I, j, k have unit magnitude, but their directions are different. I along x direction, j along y direction, k along z direction. After unit vector, let's see some different vectors. Suppose 2 vectors in a same plane. Suppose A and B are on the same xy plane. This is A, this is B. Since these 2 vectors are in the same plane, therefore such kind of vectors are known as coplanar vectors. These are known as coplanar vector. Again, if 2 vectors in the same plane lies in the same direction, suppose 2 vectors A and B lies in the same direction, then these kind of vectors are known as collinear vector. If 2 vectors started from the same point, suppose A and B, then these kind of vectors are known as co-initial vector. Besides this, some other vectors, like if 2 vectors are in the same directions and they have same magnitude. Suppose A and B are in the same direction and they have same magnitude, then these 2 vectors are known as equal vectors. Here A equal to B. So this is known as equal vector. If two vectors have same magnitude but they are reversed in direction, suppose this is A, this is B, then these two are negative to each other. So these are known as negative vectors to each other. Well, sometimes a strange kind of vectors observe. Suppose a vector A and another vector minus A. Look, A and minus A have same magnitude but the directions are opposite. If we combine these two vectors, then the result is zero vector or null vector. The null vector have a zero magnitude and therefore it has no specific direction. So through this way we will encounter this kind of vectors in our later parts of study. Now vectors, as I have already mentioned that vectors need special kind of mathematical operation. If we want to add or subtract a vector, then there have some certain rules and methods. So now we will study about vector addition. Vector addition. There are two ways of vector addition. One is graphical method. Another is analytical method. In this lecture, I will focus only on graphical method. Graphical method is nothing more than pictorial representation of vector addition or subtraction. So graphical methods contain two kinds of methods. One is known as triangular method and another is parallelogram method. Triangular method is sometimes known as head to tail method. Now we study on triangular method. So what is triangular method? Suppose two vectors in a plane. One is A, another is B. If we want to add these two vectors, then there is a method known as triangular method, where one vector's head is connected to the other vector's tail. Therefore, it is also known as head to tail method. So here, suppose if we write B vectors, we will not change the direction of B. Just write the B vectors here, and we add the head of A vectors, maintain the same directions and connect like this. Then these two vectors can be added and their addition vectors is in the direction of this way. So A plus B. This is known as, so this is a triangular shape. This is a triangular shape addition. Therefore, it is called triangular method. So it gives a triangle. So another is the parallelogram method. In case of parallelogram method, the same two vectors A and B are connected like this. Here the resultant in this direction. How? Because if we draw a parallel vectors here, it is similar to a vectors. If we draw a parallel vectors here, it is similar to b vectors. By applying the simple triangular method, we get a plus of b. So these two are methods useful for vector addition. Now vector subtraction. Subtraction of vector. Suppose a vector A, another vector B. So A plus B like this. But if we take minus B, here B will, the direction of the vector will changes. Now if we add these two vectors by triangular method, then we see here this is A vector, okay, and this is B vector now. So now the direction of the resultant vector will be this, and this is known as vector subtraction. Remember that the vector addition holds commutative as well as associative properties. That means vector addition commutative property means A plus B is equal to B plus A, and associative property means A plus B plus C equal to A plus B plus C. So these two properties are associated with vector addition, or these two properties are holes. These two properties holds in vector addition. But in case of subtraction, these properties are not be possible, since that means A minus of B is not equal to B minus of A. Well, now we will study about vector multiplication. So multiplication of vector. At first, we will study on how the vector changes when it will multiply by a real number. So number 1, multiplied by real number. So any real number, suppose any positive real number, if we multiply a vector with a positive real number, so says 2 to a vector A, then it is twice A. That means if original vector is A, after multiplications by 2, then a vector length will increases, but its direction remains same. Therefore, if we multiply a vector by positive real number, then its direction remain unchanged, but the magnitude will changes by the factor. Factor means the number which I have multiplied to that vector. Similarly, if we multiplied by a vector by if I multiplied the vector by a negative number, says minus 2 to a vector A, then the result is minus of 2A. If the original vector A, then after multiplication the vector will appear like this. Here not only the direction changes, but not only the magnitude changes, but also the direction changes. So multiplying a vector by real number will changing the direction in some cases, changing the directions and magnitude in some case, and it will changes magnitude in some cases. But that means if we multiplied it by a positive number, then only the magnitude changes. But if we multiplied it by a negative number, then both magnitude and direction changes. Now, product of two vectors. Product of two vectors. There are two methods available for vector products of vectors. One is known as dot product, sometimes known as scalar product. Another is cross product. Or vector product. At first we will study on dot product. This is dot product. So suppose two vector A and B. If we want to do dot product, then A dot B is equal to magnitude of A, magnitude of B, cos of theta. Here we found that the right hand side has no vector sign. That means the result of the dot product is a scalar quantity. Therefore, this kind of product is known as scalar product. Here A is the magnitude of, here this is magnitude of A, this is magnitude of B, and this is the angle theta between A and B. If theta equal to 0, it means A and B are on the same line, or they are parallel. In this case, cos theta equal to 1. So A dot B is equal to simply product of their modulus. If theta equal to pi by 2, theta equal to pi by 2, here one vector is perpendicular to other. In this case, cos theta is equal to 0 and A dot B equal to 0. It means that when the vectors are collinear or parallel to each other, then their dot product is maximum. And when they are perpendicular to each other, then their product is minimum. Vector dot product holds commutative as well as distributive property. That means A dot B is equal to B dot A, commutative. And distributive. Distributive means A dot B plus C equal to A dot B plus A dot C. So these two properties are holds in dot products or scalar products. Now we will study on cross product. In case of cross product, again we consider two vectors A and B. So their cross product is like A cross B is equal to modulus of A, modulus of B, magnitude is also sometimes known as modulus, sine of theta, and with some unit vector. Here again A and B are the magnitude of A and B, and this theta is the angle between A and B, and here a vector sign appear. This is a unit vector. So the product of the cross product results always a vector, and the resultant vector's direction is perpendicular to the plane in which A and B lies. That means this unit vector is perpendicular to both A and B. Again, as we have studied earlier, here we again check the theta's value. If theta equal to 0, then again these two vectors are collinear. In this case, sine theta equal to 0. Thus, A cross of B equal to 0. If theta equal to pi by 2, then factor A and factor B are perpendicular to each other. Here, sine of theta is equal to 1. So, A cross of B is equal to AB n cap. So, this is the, here this value is minimum, and for this is the maximum case. That means in case of cross product, when two vectors are parallel to each other, their cross product value will be minimum. If they are mutually perpendicular to each other, then their cross product value will be maximum. At this point, I would like to quickly rewind what we have learned so far. We have started with physical quantities. Physical quantities are those quantities which used to measure the properties of a system. These physical quantities can be classified into two categories. One is vectors, another is scalar. Again, vectors have directions and magnitudes. Scalars have no direction, but magnitude is present. Scalars, the ordinary mathematical rules are applicable for scalars, but for vectors there are certain special rules are required. We have studied different kinds of vectors like displacement vector, position vector, unit vector, coplanar vector, coinitial vector, and so on. And finally, we have studied about the vectors addition in graphical way, graphical represent or pictorial way, by two methods. One is parallelogram methods, another is triangular methods or head to tail methods. After this, we have studied also about the multiplication of vectors and subtractions. In case of multiplications, we have studied three different kind of product. One is a vector multiplied by simple real number. If we multiply a vector by a positive real number, then their magnitude increases but direction remain changed. But in case of multiplying a vector by a negative real number, then both direction and magnitude changes. In case of dot product, if we multiply two vectors, then their product will be a scalar, and the vector dot product holds commutative as well as distributive property. But in case of cross product, their result is a vector quantity. Therefore, it is also known as vector product. And we also found that when two vectors are parallel to each other, then their cross product value is minimum, and if they are mutually perpendicular to each other, they have maximum value. At this point, I want to stop this lecture. Thank you.